Hello girls, I hope you're staying safe at home. In chemistry, today we are going to start with a new chapter, that is ammonia. You know the molecular formula of ammonia is NH3 with a relative molecular mass 17, and ammonia is a covalent compound which contains a lone pair of electrons. Now you find ammonia in the free state in small amounts in air or in traces in natural water, and you find it in the combined state in many ammonium compounds like ammonium chloride, ammonium sulfate, and ammonia and ammonium compounds. Since they are very soluble in water, they will never occur as minerals. Okay, now sometimes when you're standing near a decaying heap of organic matter or a toilet, you get a very bad pungent smell, and that smell is due to ammonia. It is produced by bacterial decomposition of urea that is present in the urine. So this is the equation here. You can see how urea is broken down by bacteria to form ammonia, water and carbon dioxide, and the bad smell that you get is the smell of ammonia. Now there are different forms of ammonia. In the gaseous state as dry ammonia gas, and when the dry ammonia gas is liquefied, it is turned into a liquid by applying high pressure, then it is known as liquid ammonia. And when ammonia is dissolved in water and it turns into a saturated solution where no more of ammonia can dissolve, then it is known as liquor ammonia fortis. It is also known as 880 ammonia. It has a relative density of 0.880, and liquor ammonia fortis is stored in tightly stoppered bottles. Tightly stoppered bottles means tightly capped, tightly closed bottles, and it is stored in a cold place, and it is used as a laboratory bench reagent, which is nothing but dilute solution of liquor ammonia, which is used as the laboratory reagent. Now, there are general methods of preparation of ammonia gas. In general, it can be prepared by warming an ammonium salt, either ammonium chloride or ammonium sulfate, with caustic alkali like slaked lime, calcium hydroxide, caustic soda, sodium hydroxide, or caustic potash, potassium hydroxide. So your first assignment, you are going to write down the general methods of preparation of ammonia gas. These equations you are going to write down. Here you can see ammonium chloride with slaked lime, calcium hydroxide when heated will form calcium chloride, water and ammonia gas. And when you take ammonium sulfate and heat it with either calcium hydroxide, sodium hydroxide or potassium hydroxide, you will get the respective sulfates, either calcium sulfate, sodium sulfate, potassium sulfate, along with water and ammonia in all the three cases. Now next we move on to the laboratory preparation of ammonia. Now in the laboratory, the reactants used are ammonium chloride and calcium hydroxide. Now in this case, you know ammonium chloride sublimes on heating, so for that we need to be very careful. So we take excess of calcium hydroxide is mixed with ammonium chloride so that ammonium chloride does not sublime. It is covered with calcium, lots and lots of calcium hydroxide. So this is the reaction. Ammonium chloride plus calcium hydroxide gives calcium chloride, water and ammonia. So this is the apparatus. You can see that the reactants ammonium chloride and calcium hydroxide in excess, they are finely grinded into a powder and they are put in a round bottom flask here, and you can see the round bottom flask is in a slanting position. Okay, and when this is heated, ammonia gas is given out. Now why is this round bottom flask tilted in this way? Because you know in this reaction water is formed, and this water should not trickle back into the heated flask, because if it does, it will break the flask. And here you can see a delivery tube leading from the round bottom flask into a drying tower which contains quicklime or calcium oxide. Because this ammonia is not dry, it contains water vapor, so that water vapor must be absorbed, so it is passed through the drying tower. And the ammonia gas which comes out from here, it is completely dry, and it is collected by the downward displacement of air. Now, why is quicklime used and not other drying agents like sulfuric acid, phosphorus pentoxide, and anhydrous calcium chloride? The reason is very clear: because it reacts, because ammonia is basic and it reacts with them. Your next assignment for today, you will write down why other drying agents are not used to dry ammonia gas, and you'll write down these three equations. Okay, so ammonia and sulfuric acid, you can see it gives ammonium sulfate. Ammonia, phosphorus pentoxide will give ammonium phosphate, and calcium chloride with ammonia will give an addition compound. And as I already told you, ammonia is collected in inverted gas jars by the downward displacement of air. Now why? Because ammonia is lighter than air, and air from the gas jar will be pushed out. And another reason is ammonia is highly soluble in water, so we cannot collect it over water. Now, I already told you why we used more of calcium hydroxide. Higher ratio by weight of alkali is used because ammonium chloride sublimes on heating. Okay, and why are we using calcium hydroxide? Because it is cheap and it is not deliquescent like other alkalis. Though all ammonium salts on heating with alkalis give ammonia, but ammonium nitrate and ammonium nitrite do not give ammonia on heating. Why? Because they decompose on heating. Okay, so here you can see ammonium nitrate and ammonium nitrite, how it decomposes on heating. Next is the preparation of ammonia from metal nitrides. Okay, when we heat metal nitride with warm water, when it is treated with warm water, you will see like magnesium or aluminium, but this method is very costly, it is not used. You may get and explain why. Why can't you prepare ammonia from metal nitrides? Okay, what do we do? Warm water is made to react with nitrides, magnesium nitride or aluminium nitride. Okay, magnesium nitride or aluminium nitride with warm water. You'll get magnesium hydroxide and ammonia, aluminum hydroxide and ammonia. But this method is not used. Why? Because this method is costly. Now, this is the apparatus. You can see magnesium nitride or aluminum nitride is kept in a round bottom flask here. You can see, and there is a thistle funnel through which water is poured in, and a delivery tube is leading out into a drying tower, okay, with calcium hydroxide, because you know water will be there together with ammonia and it needs to be dried. And again, you know, ammonia is collected by the downward displacement of air. So ammonia gas which is liberated, and magnesium hydroxide and aluminum hydroxide is formed, and those remain back in the flask. And only ammonia, since it is a gas, it escapes through the delivery tube. The ammonia gas formed is collected by the downward displacement of air. Okay, so you can see the jar is inverted with its mouth in the downward direction. So the gas can be dried by passing it through quicklime, which is packed in a drying tower. Now next is preparation of aqueous ammonia. Now an aqueous solution of ammonia is prepared by dissolving ammonia in water. So the rate of dissolution of ammonia in water is very high. Therefore, back suction of water is possible. So to avoid this, you can see a funnel in this diagram, how aqueous solution of ammonia is prepared. Okay, so ammonium chloride and calcium hydroxide in the round bottom flask. It is tilted, and the delivery tube through which the produced ammonia goes, it is attached to a funnel so that back suction does not take place. Okay, and remember, this process is similar to the method that we did in hydrogen chloride chapter, how the hydrogen chloride gas was turned into hydrochloric acid. So it is similar. So you can see water is taken in a container. So water is there in a container here, and only a small portion of the mouth of the funnel is dipped in water, just the tip, okay, is there. So as ammonia dissolves in water at a high rate than its production here in the flask, the pressure in the funnel above the water level decreases for a moment, and what happens? Water will rush back into the funnel. As a result, the rim of the funnel loses its contact with water, so there is a gap formed between the funnel and the water. So since the ammonia produced pushes the water down, the funnel again comes in contact with water again. So in this way, ammonia dissolves in water without back suction of water. So this is all for today, children. We will stop here. So until next upload, stay safe. God bless you.